Hi, everyone. Welcome to today's meetup, which is going to be about security. And James is going to be presenting to us. He's our security solutions lead. We're always looking for interesting talks. So if you're interested in presenting on one of our meetups, you can always let us know. And yes, I'm going to give the floor to James now.
Perfect. Thank you, Dalia. So hi, everyone. My name is James, as I was saying. We're a small group today, so we can keep it quite interactive. So just introduce myself really quickly. I am on the solutions architecture team at Elastic, focusing on security. A long-time user of the Elastic Stack for about 8 years now. Joined the company just over 2 years. And my job at Elastic is essentially to help our users, our customers, our community to implement Elastic for security. There's Elastic over the past couple of years has been very heavily focused on the security story. So I'm going to give a bit of feedback about that and like where we've came from and where we're headed. But then I'll also be diving right into a demo. So I won't spend too long on slides. Feel free to ask questions at any time in the Q&A section. Just allows us to keep track of any questions you have. And then I can take some live questions towards the end as well. All right. So first of all, just in case any of you here aren't too familiar with Elastic, I always like to start with what is Elastic? Like, what is it as a company? What does it do? What is it as a technology? So it's always good to start off with that intro, and then we'll talk about where we fit into security. So, you may be using Elastic every single day without noticing. Elastic, whether you're using something like Uber, something like Yelp, or perhaps Tinder. I don't know, I'm married, so I obviously don't use it myself. But all of these technologies are powered by Elasticsearch because Elastic started off as a search company. So even things like Wikipedia, if you type or search for anything inside of Wikipedia, that's actually being powered by Elasticsearch. So Elasticsearch is the search technology behind all these different platforms. It's probably easier to say, which products don't use us today because most of the products that have search are using Elasticsearch in the background. So that's where we started, right? So we tried to solve the search problem. And very quickly from there, we started shifting into other use cases purely because of its open source nature. So Elasticsearch is open source, will always be open source. Obviously, we do have some commercial features which are still open coded, but at the core, most of the functionality is free 100%. So that means one day someone decided to put other data than just data someone would search through inside of Elasticsearch, including things like security events. And I always like showing this slide. So if you've been at any of my other meetups or talks, you would have seen this slide before. But this really sums up what we cover from the security side, like just being able to search for that bad actor. Like sometimes we forget that most of the job of a security analyst or security practitioner is looking for bad things. So the concept of threat hunting, obviously having inbuilt detections to help you with that, but just being able to sift through tons of data in a platform that can survive those searches has been really beneficial. And this is where Elastic has pretty much entered into the security space. That's how we started off. And today, hopefully you'll see the strides we've taken to grow beyond just using us to search through events. And the slide also ties into this because security isn't something you're going to solve overnight, right? I'm a big firm believer that it's a periodic journey over time. You're not going to go from nothing to 100% quickly or ever, if that's even a thing, the 100% security or security coverage. So at Elastic, we treat it the same way, right? So we started off being used as a platform purely to handle vast amounts of data for threat hunting, for searching through, working alongside other security tools you may have. But now we've started a mission to add on more and more features that analysts can use to help them do their day-to-day. And we focus on these three things, right? So like these are the three main sort of pillars we like to talk about when it comes to security. Eliminating those blind spots. So if maybe some of you are security practitioners there, but we all know this problem, right? So you need to find a threat, you're going through an investigation, and you're doing some sort of research, and all of a sudden you found out that there's some log that's missing. You'd have to go onto the device itself, load something up into Excel, so it's a big pain. So at Elastic, we're really trying to stop that problem, eliminating blind spots by putting any data inside of Elasticsearch. We're pretty much data agnostic, and also being able to handle that at scale, which is the next item on this list, which is the scale of today is not gigabytes, it's petabytes. That's just the reality of things. And being able to be a platform that can do that, handle that level of data, is pretty significant. Elasticsearch scales as much as you need it. So that's actually one of the other reasons why it became so popular in the space, because you can just scale as your needs grow by just putting another node inside of a cluster. We're going to get into the terminology of the components of Elastic, so don't worry again if you're not too familiar. But that's also something that really ties into what we're trying to do. And the last thing is being able to arm every type of analyst. What do we mean by this? So we don't want someone to have several years experience to be able to use Elastic Security. Or on the flip side, we don't want someone who has that level of experience to not feel comfortable when using Elastic. So we really want to try and cover as many personas as we can in terms of usability, features, and depth of sort of search capability and querying capability. So there's a lot of stuff we're trying to cover to be able to handle as many different skill levels as we can, and that's something we're firm believers in. We don't want to just arm the experienced; we want to arm everyone. And this is why on this slide you're seeing unified protection for everyone. So this is another thing. With Elastic, as we already mentioned, it's open source, so a lot of it is free. Even under what's something we call the basic tier, it's free forever. And we're trying to do that for everyone. So it's not security for people with $1 million budget. It's not security for just businesses. You can run this at home if you wanted to. Like you can just literally just grab an Elasticsearch cluster, turn on the defaults in our SIEM, and have a really nice capability to detect threats. And whether you're again someone who's just starting something on the side, or you're a massive business, or someone who wants to do security at scale, it's going to be for you anyway. Today, I'm also going to talk about something we're introducing in the upcoming release. It's pretty exciting for us. We recently, when I say recently, about 9 months ago, as of today, we joined forces with an endpoint company called Endgame. And in the past couple of months, we've been really working hard to make their technology available as part of the stack natively. And today I'm going to give you a peek into that. It's not out yet. It's in the next release of the stack. But some of those features, so fully fledged enterprise grade endpoint features, are actually going to be made freely available as part of the basic distribution as well. So really happy to be able to show you some of this today. I hope you're excited when you hear that, because this means you're going to have amazing opportunity to not only spot and detect threats, but also prevent them with anti-malware capability. So we're going to be looking at some of that today as well. I'm quickly going to cover the stack, again, just in case any of you aren't too familiar with the terminology. Because Elastic is a stack technology, it's not a singular component, it's not a singular product. So it's good to understand where the different parts play into it. So at the core of everything, there's Elasticsearch again. So this is the technology that is powering the Wikipedias and the Ubers and all those applications. And we started off just from here, started off just from Elasticsearch, which is a horizontally scalable, distributed search engine. That's literally what it is. Elasticsearch is always meant to run as a cluster, so you should have a node, a singular, what we say, node of Elasticsearch. You should have a minimum of at least 3, and then grow from there depending on your data needs and your data sizes. So at its core, everything we're going to be seeing is using data that's stored in Elasticsearch. Now that we have data store, we need a way to work with it other than just APIs, because Elasticsearch is first and foremost RESTful as a RESTful service, so it's totally API based. But we also need a way to bring data in. And these are where the other components come in. So we have our ingestion layer highlighted in blue here. So these are different ways to get data into the stack, mainly log or security related event data. We have 3 different things here, and soon to become, I would say, some of these things are going to start joining, but we start off with beats. Beats are very lightweight data shippers. So essentially, you'd grab a beat, install it on a server, on a laptop, on a Docker container, cloud machine, wherever you like. Depending on the type of data you want to collect, you can either enable a certain module, and I'll talk a bit about these in a second, or you can install a different beat. So there's actually a family of about 8 different beats today that we support ourselves. So if you wanted something like packet data, there's a beat for that. If you wanted Windows event logs, there's a beat for that. And then there are beats like file beat, which can also act as like a syslog server. They have modules for things like AWS and Azure and GCP and Palo Alto Firewall. So there's, I can't even keep count of the number of integrations we have, but these are primarily handled by Beats. The initial use case for Beats was just collections from a host. Now it's grown beyond that, and they're very, very powerful. They're written in Golang, so they're quite lightweight and pretty performant as well. And from Beats, you can send data straight to Elasticsearch if you wanted to. So just to clarify that, so when you're collecting data from Beats, it can go straight to Elasticsearch. If you need to use a broker in between, something like Kafka or something else you prefer, you can as well. Before I talk about Endpoint, let's talk about Logstash. So Logstash was the actual first way of bringing streamable data into the Elastic Stack. Logstash is more of like a server-side component. So you set up a Logstash server, and then you can stream data to it via syslog, TCP. You can read from relational databases. You can query RESTful APIs. There's like 200 different Logstash plugins, depending on how you want to bring data in, manipulate it, and then output it. Because another really popular use of Logstash is like as a data router. So you can actually have multiple outputs from Logstash. You can transform the data. You can add fields. You can pretty much do whatever you want. Logstash is very, very popular because of how flexible it is. And this is where if you've heard of the ELK stack, this is where it comes from: Elasticsearch, Logstash, and Kibana. After we introduced Beats, we decided to call it the Elastic Stack as opposed to the ELK stack, because ELK-B or BELK or BELK doesn't sound too great. However, you can call it whatever you like. The last thing you're going to see here is Endpoint. So I'm going to be talking about this today because Endpoint, apart from being able to detect and prevent threats, it's also a fantastic source of telemetry coming from the hosts. So we'll collect things like process information, user information, network requests, pretty much anything you can think of via this agent as well. So it is, of course, another ingestion data source for sure. So now we spoke about where the data is going to sit and the core of everything, how we're going to bring data in. But the last thing we need is, being able to use this data. So it's pointless having, terabytes of data if they're all stuck in a place and we can't use it, right? So this is Kibana. This is where Kibana comes in. So Kibana is our visual window into the stack. So this is where you're going to create your searches, where you're going to use the out-of-the-box content, where you're going to create SIEM rules and detection rules. This is where you're going to create cases and do investigations. It's also where you're going to monitor and manage the entire stack. So Kibana these days has grown to be able to serve all these use cases. There's a lot of stuff you get from day one out of the box as well. And of course, you can build anything you like. There is zero restrictions in what you're able to build via dashboards, canvas workpads, maps, even if you want to do your own custom plugins as well. So there's no limitation there either. This security portion on top is basically the content that we provide out of the box in Kibana. So like the detection rules I was mentioning, the workflows, this is all part of Kibana. So it's not like an additional module you need to install. It's just natively part of the stack. And that's sort of our goal here. We've had so many people use us over the years, myself included, where we had to build our own content to use Elastic for security, that just about 2 years ago now, we made the decision to start formally building a security solution ourselves, purely because we knew how many people were using us already. The last thing you'll see on the slide, which is very near and dear to our hearts, which is one of the reasons why we have these meetups, is we're all about community. Like we wouldn't be where we are now if we didn't have the community backing we have. And in the security space, this is extremely important. So it's like, even when I was using it as a user and as a customer, I could literally search any particular technology and find a solution that someone has built and shared to the community that I can reuse. We have our Slack channels, we have our discussion groups. There's so much community interactivity going on in the security space, but also in some of our other use cases. It's pretty phenomenal. We always keep the community at the heart, and being an open source company that ties right into what we're trying to achieve. So very quickly, we went over the stack. Obviously, you're going to see this as I go through the demo, but I wanted to very quickly go over the different components in case there are some people who aren't too familiar. That being said, I'm going to just jump right into a demo. There's two parts to my demo today. One is features that exist as of now and today. And I'm going to give you a sneak peek into what I've been talking about this new features, about the endpoint, and even some upcoming releases that we have pretty much around the corner. So that being said, I'm going to just dive right in. And I'm going to head to my Kibana. So for those of you who've never seen it before, this is Kibana. As of today, it's running the latest version, which is 7.8.1. We have a very regular release cycle at Elastic. So even if you used Kibana or the stack a few months ago, it might look entirely different. If you used it a year ago, it definitely looks different. If you used it a couple of years ago, you're probably thinking I'm lying to you that this is Kibana. So like there's just so much going on and very frequent changes that sometimes it's hard to keep up. So I just want to point out that the version you're seeing is the latest as of today, which is 7.8.1. My Kibana's in dark mode as well. Obviously, we're talking about security, so it has to be dark. Of course, there's no other way. But by default, you'll see a white Kibana, just in case that's confusing you as well. All right, so what am I looking at here? So I'm running the stack for this particular demo, and my particular demo instance is running in our cloud. So we do have a fully hosted SaaS solution. However, you'd get the same experience wherever you run it. Doesn't really matter, whatever your preference is. I just always find cloud services to be the easiest to consume, but you can run the stack via Docker. You can have our own Kubernetes operator. You can download the individual packages and run them together, however you prefer. You can even run Elasticsearch on any laptop if you wanted to just especially to test and experiment. I am particularly in the SIEM section. Obviously, we're going to be talking mainly, about security today. If we have time, I will touch on some other things we can use in Kibana around security as well, because it's not just the SIEM. I think this is pretty important to highlight. You can use any part of Kibana for security. So even though there's the SIEM and most security people will stick to it, you can use any part of Kibana that you like. We're not going to stop you. And I'm also going to point out that these are not things you have to download and add yourself. These are all there from day one. And in the background, even though there's multiple use cases, it's one cluster. So we're reusing the same data across multiple different scenarios. There's never a concept of you having to get data and shift it somewhere else or anything like that. If it's in the same cluster, it's just going to work. When we start off in the SIEM, we got a nice overview page of what we're looking at. So in this environment, it's live. There's quite a bit of data coming in. The data I'm focusing on today is from a few days ago because I ran a malware sample to generate some events. But I still have data streaming in real time. Before I dive into Kibana itself, actually, let me show you a bit of context here. So I have a Windows Server machine. So just a plain and simple Windows Server 2019 running in Google Cloud. And I detonated a real malware sample here. So for those of you familiar, this is based off of the APT34 group, sometimes known as Helix group. It was a phishing campaign, which this was the exact same email. You double click that Word document, and if you decide to enable the macros, it does a ton of stuff in the background. On this same machine, I am, of course, collecting data from it and sending it to Elastic. I have a couple of different beats. So I have primarily WinLogBeat to collect Windows events. I'm also using Sysmon on this machine. So Sysmon is a tool provided by sysinternals to be able to really do in-depth data collection types. Like if you're familiar with things like event tracing for Windows, that's what Sysmon uses. I'm also running PacketBeat to get network data as it passes over the network interfaces. And I am running some of our endpoint technology as well. So I just wanted to show you a bit of context into most of what we're going to see from a detection standpoint. And I'll also note that from a collections perspective, from the beats, it is the default module. So I haven't done any work in terms of custom data parsing or anything like that. It's literally the default options that you get when you download and run the beats. So let's switch over back to Kibana. And let's take a look at the SIEM and what we're able to see, and also what we've detected as a result of that malware running. So in the overview page, I mean, it's pretty straightforward. You get a couple of different charts about the environment you're working in. So these charts are, again, pre-populated based on the data you have. You can change them around in terms of what they're stacked by and the time ranges, of course, and you can search in the traditional way. However, you cannot really manipulate this overview page apart from that. So you can see here, signals are basically detections. So what has triggered in my environment. And again, these are all after I ran that sample. So I'm looking at quite a wide time range here, but you can see there's a few different rules that were triggered as soon as I clicked that in the very beginning. So that's just an overview of what was detected. We also show separately external alerts. So, at Elastic, we're not going to force you to use our data collections or our technology or anything like that. From a data standpoint, you can send any data you want, including data coming from other existing security devices or security software. So if you have, I don't know, an IDS or a web application firewall, or an next-gen firewall which has its own alert set, or an endpoint technology that you want to send to Elastic, we will visualize those alerts anyway as external alerts. So in my case, for example, I have Suricata as one of those, which is an open source intrusion detection system. So we're able to show you those as well. We made that distinction there. Here we have a breakdown of the events. And again, everything you're seeing from these event types, these are all default. So I have not had to do much work at all to bring this data in other than running the beats. And you can see here, this is just a small list of the beat types and the beat modules, but we do break it down specifically for the most common security event types. But all this data is the default from the beats. So I just want to keep emphasizing that I haven't spent like months parsing things here. A couple of other things on this overview page. So we have a breakdown of the most recent cases. So we do have case management inside of the stack, typically used for incident response and incident investigations and just collaborative effort when you're looking at an incident. We have the concept of a timeline. I'll get into more detail about this, but the timeline is a really nice graphical way of running a security investigation. We also have a news feed. So, at Elastic, we have a very, very talented security research team and detections team who are constantly looking at new threats. They're looking at new vulnerabilities, new malware samples. And we wanted to give them the ability to publish any new findings straight to the users of Elastic Security. So rather than us sending like a mass marketing email or sales email or anything like that, we actually publish it straight to the people who need it most, which is the users of Elastic Security. So that's what the security newsfeed is. You can see, for example, the latest one was around the DNS vulnerability 2 or 3 weeks ago. So our detections team put some rules together. We shared this blog post, and we talked a bit about it as well. You do have the option to turn this off if you don't want it, but by default, I think it's really, really handy to have on. All right, so that's the overview page. Let's dive into the detections at this point. So, most of this, I would say most of the analysts using SIEM would start off in the detections page. So remember, detections is, what we've detected as potentially malicious activity. This version of the stack ships with 148 detection rules out of the box. So again, you pick the ones you want to run, tick a button, and they're running. And you can see here, there's various different types. I'm just going to sort by ascending order here in time. And you can see things like suspicious process spawning PowerShell, spawning from script interpreter, Windows script executing PowerShell, local scheduled task commands. And these all were detected after I ran that sample. So this is a real sample, so it's not something I fabricated. And these are default rules. So you get a lot of value just from the defaults already. What can an analyst do to start using the screen, right? I think it's pretty important to understand the different components we have here. So these detections, there's a few ways you can start looking at them in terms of root cause analysis. The first thing you can do is you can send a detection that was triggered immediately to the timeline to start investigating, which is this nice little button here. If I click on this, it will fly open the timeline, which is here on the side. It will filter for that specific detection, and then I have the full sort of log where it triggered. So I can see here, for example, this one was local suspicious process. So I can see all the process arguments. I can see pretty much everything that was gathered. I can see the query. So we do contain all the rule metadata here. We give a description. So I can start investigating this way. The timeline does allow, I'll get into more detail, but I can drag different items into the timeline. So the nice thing about it is It's totally dynamic. I can get any of these fields and just drag them in here. I can do pretty much whatever I want, and I can build my queries really easily, especially if I'm not too familiar with the syntax, the search syntax. But personally, if I was an analyst looking at these events, I probably wouldn't start off from just one, especially if I've noticed that all these different events are happening for the same host. This this James Honeypot Windows 30 host. So one thing we can do is, instead of going into every single individual alert, we can dive into a host context. So I can literally just drill down into this host, and this is going to show me the host view. So everything that's going on that individual host. You'll also notice at the top here, I have a lot of metadata about that host. So part of the job of the beats is not only to send data, but it's going to gather as much metadata about that host as it can. So in my case, because it was running in Google Cloud, I get the cloud provider info. And again, this happens automatically for most cloud providers. I get the operating system info. I get any interfaces that are on that machine. So this is all picked up. So really, really handy to have that in the same context. We won't talk about too much about this today, but we do have, as part of the commercial offering, unsupervised anomaly detections. So basically, we have machine learning in the background looking at data and modeling it. And in the event where we notice something, we would actually give you an anomaly score here. And we also get a detection rule. So in our case, we actually had one representing DNS tunneling, because that malware sample actually did that. So just to highlight, that is one of the commercial features. Again, we won't get into too much detail about that today, but it is another level of detection that you have out of the box. So these are out of the box machine learning jobs as well. So we want to try and get to the root cause of what we saw in all of those alerts, right? So one thing we have here is some quick ways of starting. So depending on how you like to go through your theories of investigation, you might want to start with authentication. So I can see here, apart from system, James Spiteri was the only person who had successful authentications. We also list out things like uncommon processes. So you can actually see the processes that were ran, how many occurrences there were, and also their arguments, right? So we list out all the arguments that that process had. We have quite a few going on here. What I like to do is actually look at the instances number. So sometimes having one instance is suspicious, but sometimes also having an odd number is suspicious. So you can see here, I'm just looking through them quickly. We have things like scheduled tasks, and we saw some alerts around scheduled tasks. So we might want to look into scheduled tasks. We saw, if we keep going more, there's a lot of PowerShell and a lot of W script, and in the 2000 range. So that's a bit suspicious for me. And again, this is all happening for that same user we saw before. So depending on how I want to go about this, maybe I want to start searching for events around PowerShell. Maybe I want to start searching for events around James, or maybe I want to look into the arguments, right? So I'm looking at these arguments, and as a security analyst, if I see something trying to bypass the PowerShell execution policy, that raises some flags. I might want to look into that. So it's a really nice way how we can pivot from here to actual searches. So we're going to use the timeline for this. So I'm going to open up the timeline here. I'm going to start a fresh one. And what I'm going to do is I'm going to focus on that PowerShell theory to start. So I'm just going to grab PowerShell here, and I can send it to the timeline either by clicking this button, or I can actually drag and drop as well, if you prefer. So you can see I can just drag process name PowerShell. And what this is going to do is it's going to search all my data sources within that time frame for anywhere I find process name PowerShell, regardless of what type of data source it is, where it is. It's going to search all of it. And this is powered by something we call the Elastic Common Schema. The Elastic Common Schema is a way we can normalize the events across all the different data sources. If we have, so for example, all our beats and all their modules are using the Elastic Common Schema. So if you use the beats, there's no work for you to do. It will all follow the common schema. If you're bringing your own data sources in, there's multiple ways how you can adapt your data to the common schema. Think about it as a field naming convention. This is my cat mouse. But it's really, really handy for doing these sort of searches, because now I can just do one really simple search and it's going to search all my different data sets. So we've searched for PowerShell, and we can see within that time frame, so within a 6-minute period, we had 128 instances of PowerShell. we may want to widen this a bit. Why don't we do a bit more? Let's go to the 11th and update that. And now we have 35,000. And you can see as well how we didn't wait. So they just loaded up. And another nice thing about the timeline is we're doing something we call event rendering as well. Not for every data type, but for most data types, we have this what we call rendering. So it's really easy to read like a story. So for example, here we have, hey, this user in this domain on this server started PowerShell with these arguments via this parent process. So just to point that out that this is happening for you automatically for certain data types, it just makes it really, really handy when you're going through these investigations as well, because it's much easier to read data like this rather than having to open up all these events and going through them all manually. It saves you a tremendous amount of time. We can see here around PowerShell in that time period, there's a lot of these DNS requests for withyourface.com. If you remember that when I spoke about the machine learning portion, the DNS signing it detected was around that name. But you can see here how there's a lot of DNS requests for these unusual subdomains with withyourface.com. So one thing I can do is I can pivot onto that theory as I'm going through this and try and find out what happened with this withyourface.com domain. There's several ways to do that. I can either drag an element here, so I can literally just drag this as it is from here into the timeline again and keep building my query. I probably want something a bit wider than that because I want to search for everything. So either I can open up one of these documents and see if there's something I can use from here to narrow down my query more, or I can, if I want to, type in the traditional way. So I can still filter by typing. So for example, I can do something like dns.question.registered domain. I can do withyourface.com, for example, if I remember how to type. So I can still search like that and see if I have any events. In fact, yes, I do. And I can keep building my query like this and see what happens. So there's still all those DNS events. So what is this domain? I can go look it up, for example, if I wanted to. Maybe I'm only interested as well in seeing if I had something with those bypass arguments. So one thing we saw before, so what I can do is I can do this. I can switch from an and to an or, and then I can search for other things as well. So maybe I want PowerShell.exe or this domain or wherever I have PowerShell and the specific argument. So I can do, for example, or process.args bypass, for example. So looking for those bypass arguments as well, that is something I can do. So depending on what I prefer looking for or where my threat hunting theories take me, I can do that again. And you can see it's still mostly around that PowerShell activity. There's quite a bit going on. And I can keep narrowing down my events like this. I'm not going to go through the whole workflow. Of course, that can take quite some time, but I want to highlight some other things we can do when doing these investigations. So the timeline allows me to be really interactive and collaborative. So as I'm going through this, I can start leaving some comments or notes. So I can just go in here, for example, and say, hey, this is suspicious, for example. And we support full markdown syntax here. So if you want to leave screenshots, images, you can pretty much do whatever you like. You can also leave these notes at a more generic timeline level if you wanted to. So I can leave a note over here as an example. And this sort of, it's more of like saying, hey, I did this, this person did this, for an audit perspective or something like that. It's really, really handy, or handing over to another team or some other member of the team. I'm actually going to give this timeline a name, because when I give it a name, and then it also allows me to create a case. Before I create the case, I'm going to save this search. So I'm going to switch this back to an and I'm going to save the search. So I'm interested in this, saving it. And why I want to save it is I want to now create my own custom detection rule. So imagine I went through this whole workflow. I've narrowed it down to the behavior that I've saw. And instead of relying on the detection rules only, I want to create my own custom rule to detect this specific activity across my environment. So we're going to go and save this query. And when you save a query, it allows you to save it and use it across any other part of Kibana or the SIEM. So that's really, really handy. You can save a query in one part and use it anywhere else. I'm going to save it so we can build our own detection rule from it. So I'm going to call it meetup query, save. Now, before I create the detection rule, I am going to kick off a case because I want to start involving some other people in the team. So I'm going to go ahead and do that. And you can see from this button, I have the option immediately to attach timeline to a new case. So this is going to kick off the case creation workflow. So let's give this a name, meetup case. And you'll see this element of Markdown pretty much everywhere in the sim. So wherever you have Markdown, you can make it a really rich experience for anyone who's using this. So by default, because I added the timeline, it's going to link the timeline in Markdown. I can add any other timelines I want. So when you're going through an incident, you're going to have multiple searches. So you can include multiple timelines if you need. Again, images, screenshots, cat's trying to knock over the coffee. I can leave anything I like. And when I'm ready, I can go ahead and create the case. When I create the case, it's going to kick off this screen here. And you can see now I have an open case. It's been open for 2 seconds. I'm currently the only participant, and I was the reporter, so we do keep track of that. But as other individuals start to leave comments here, they will show up as other participants. So it's a really nice way to collaborate when doing an incident. As part of the commercial features, there's also ways you can push this to third-party systems. So for example, if I wanted to have this updated in Jira, if I use Jira in my environment, just push this button and it'll actually open up a Jira issue. So if that's something you're interested in, it is one of the features we offer. And you can see now it told me it's part of a Jira incident, and it actually links me to the Jira issue. So I just wanted to point that out as well. All right, so we created the case so other people can start getting involved. I'll show you some example cases where I had multiple people commenting. So let's take this one as an example. So I was working with my colleague, Nick. He started the case. You can see how nicely the Markdown syntax allows you to have all this detail. And then I jumped in, I left some comments, we pushed it to ServiceNow and Jira. So it's just a really nice workflow to keep track of a specific incident. You can have tags, you can do whatever you want. And also just to highlight that everything you're seeing, there's an API behind it. So if you wanted to automate any of this stuff, you can do that as well. Let's go ahead and jump into detections and talk about some things there. So remember, we want to create our own detection rule based off our saved query. So I'm going to go ahead and do that. Really, really simple. We have this manage signal detection rules button. You can see the 148 rules that come out of the box here. So these are literally all, as you download the stack, you just push a button and they're all there. We're going to create our own in this case. And you can see you have, as of today, 2 choices to create rules. One is the custom query or saved search. The other is machine learning. Let's go ahead and create our own custom query based off of that saved search. So instead of me now having to start again and build my query from scratch, I can just load up that saved search I did, which was meetup query, and then it will add anything I had in the search bar or anything I had in the timeline. So this timeline filter drop area has everything that we dragged in. We can pick a timeline template, and this will allow me that when I click that investigate in timeline button from the detections page, it will open it, it will populate with pre-existing data in the form of a template. We can give the rule, we have to give the rule a name. So meetup rule, APT34, we can give it a description. We can put in a severity rating and a risk score. We can add tags. And under advanced settings, and then we can add even more context. We can add reference URLs. We can add false positive examples. We can add MITRE ATT&CK tactics and techniques. So you'll see MITRE ATT&CK and its taxonomy referenced pretty much throughout the entire stack. I should say throughout the security app. And here we have also the concept of investigation guide. So I'll show you an example of one I built. Investigation guide is really, really handy to be able to put steps for an analyst to follow to go through an investigation. So instead of having to open up another tool or reference another platform, you can have it there, just part of the rule itself. Press continue. I must have forgotten something. Yep, description. Press continue now. Then we define the schedule. So it's going to run every 5 minutes with additional 1 minute look back time. So you can change these. This look back is essentially just an extra precaution just in case some data comes in late. So in reality, what's going to happen here is it's going to run every 5 minutes, but look at the last 6 minutes worth of data just in case. Press continue. And the last thing we have is actions. So as much as we'd all love to have 24/7 SOC with people eyes on screen all the time, that's a luxury. for most cases. So of course you can have alerts go to external systems like email, Slack, webhooks. So you can set this up. This is another one of those commercial features, but super useful to have. I will show you an example of one. So here I have a Slack bot that I built, which is having some of those alerts come in, as you can see. So you can build alerts to your heart's content, especially with that webhook connection. You can pretty much do whatever you need. All right, so I won't go ahead and create and activate, but when you're ready with the rule creation, you can just create it and have it run. If you want to come back to it and maybe finish off the creation before you actually push it to production, you can actually save it and then come back when you're finished. So that's what the creation looks like. Super simple, really nice workflow as well. So everything you can see for people who have tried to do this in the Elastic Stack in the past, hopefully you can see how much easier it is now. So we've really been trying to improve the experience end to end for our users, especially in the security world. I will show you one of those investigation guides. So if I open up one of my, excuse me, alerts that got triggered here before, I'm just going to click on it so you can see how much detail you get when you click on a rule. Like this is super handy to have because as an analyst, I have pretty much everything I need at the tip of my fingers. So I have an about description about the rule. So why was this even created? I have the false positives, reference URLs, those MITRE ATT&CK tactics. This particular one's running on that machine learning job. So it actually tells me the machine learning status and gives me a link to the machine learning page if I wanted that detail. But then under investigation guide, you can see here, I built this with GIFs and images and screenshots. So like for someone who's either never used Kibana before or have no idea how to look for DNS tunneling activity, you can make it really, really descriptive. You can also link back to other parts of Kibana, for example. So like, having Kibana to be able to calculate how much data was potentially exfiltrated is super handy. And so you can make these really, really nice and just have them in there for anyone to follow. Again, this goes into that arm every analyst that we spoke about. So we want you to be able to have this so anyone can follow. So that's very quickly about the SIEM. Just in the interest of time, I would like to talk a bit about what's upcoming because this is pretty significant. So hopefully you already got an idea of how much you get, and I'd say like 95% of what you saw is 100% free. In the next release, unfortunately, I can't give an exact date yet, but it's pretty close, really close. We're going to go above and beyond that because we're going to make a chunk of our endpoint features completely free and part of this. So especially the malware detection and prevention side. So the same malware detection technology that we inherited from joining forces with Endgame. So something tried and tested, it's on AV comparatives, really high scoring, industry standard stuff. That's going to be part of what you get in the stack. So I have here a upcoming release. It's a build candidate of that. And I do have here, as part of my data collection, I have our new endpoint running. And you can see here, again, similar alerts to what we have before, but I'm collecting them now. All the data is coming in via that endpoint. And one thing I'll talk about is how we can actually look at this data on the next version. So for example, if I want to look at local scheduled task commands, yes, we have the timeline like we had before, but we also have this graphical investigation view. So I can see how processes are spawning off of each other. I can dive into the individual events. So there are 7 file events around this PowerShell activity, and I actually get the full detail there. So this is all going to be available as part of that. But more interestingly is how is this going to be work? How is it going to be powered? Is it another beat? How's that going to work? So on the next release, apart from all the the endpoint side, we're introducing a concept of ingest manager. In fact, in 7.8, it's out as an experimental feature. But I have here, you can see now a new administration button. This is going to allow me to manage my endpoints right within this view. So what this is going to allow me to do is it's going to allow me to manage what I'm collecting and also detecting on my endpoints. So you can see here I have 2 currently active endpoints. One is a Linux machine and the other is a Windows machine. And we also give track of the policy status as well. So you can configure these policies right from within here. So for example, if we look at my policy, I have malware prevention on. I have this type of event collections. So instead of having to deploy different beats and different types, I just click to say what I would like to collect across the different operating systems. I can also detect only if I don't want to prevent files, because if I prevent files from running, it will stop malware from running. So totally up to you. And the same thing. So you can have multiple policies here. These are managed by the ingest manager again. If I click on a host, it will actually tell me, what the success was. So I can actually see every portion which might have been successful or not. So there's a lot of detail that you'd get to see which part might have failed. And on Windows, you actually get a bit more because the malware prevention is running on Windows and Mac OS here. So you can see pretty much all the detail about malware configurations, loading models. This is all stuff that's happening in the background. So there's a lot going on. And this is managed by the ingest manager. So you can see a bit of a redesigned menu as well. So now it's security with the multiple different options right within here. It's not just SIEM anymore. If I go to ingest manager, this is a new concept that we have in Elastic for integrating different data sources. And endpoint security is just for us considered another data set. So instead of you again having to worry about beats and modules and what am I going to run, you can basically pick and build a package that you will deploy to your different systems. Endpoint security being one of them. So if I just click this, it will basically give me all the information about that. I can add it as an integration, and I can push it out to my hosts. It's literally going to be that easy. And again, 7.9, and you can see the version there. So the next release, which is 7.9, it's going to be in beta. So try it out, your heart's content, and use it. Eventually, we'll move towards having it generally available as well. But there's a lot to talk about. I just really wanted to highlight that endpoint side because it's obviously a big change as well. You're going to get industry grade endpoint protection to start totally free. So like particularly the malware detections and prevention side. So I really wanted to highlight that and make you aware of it. So as soon as it lands, as soon as it becomes available, you try it out and test it. There's obviously a lot more coming in the next release. I can't talk too much about it. I just really wanted to show you the endpoint side of things, but there's a lot coming out in the next release. I can mention things like there's going to be around 50 or so new detection rules coming out, particularly focused on cloud-based events. So if we look at if we go to detections, that number's jumped to 203, I think. So we've focused our efforts a lot on cloud-based and DevOps-based certain scenarios. And there's a lot coming. So keep an eye out for this release. It's going to be pretty spectacular. One more thing I'll mention in 7.9 is, we've been working towards introducing a brand new query language, which is the event query language. So this is, again, something we inherited from Endgame. And anyone who's tried to do security searches or security-related detections in the stack, it was really hard or almost impossible to do correlations, right? We didn't really support that as a technology. EQL is going to allow us to enable that. So you can see here I have some examples where I'm searching for a sequence of events by a process ID over a 1 hour span, for example. So you'll be able to run these sort of searches. And in 7.9, it's going to be introduced as an API like this. Eventually, it will make its way as natively as part of the SIEM. So you can build super sophisticated detection rules. We'll be able to build them as well, and you'll be able to correlate and share and distribute to your heart's content. The last thing I'll mention, talking about detections and all that stuff, is a couple of weeks ago, we made our detections repository totally open. So if you look at GitHub, here we go. In fact, it's my number one there. This is a totally open repository where you can see what rules we're building. You can grab any of the existing rules. So you can see in the next release, for example, there's a whole directory for AWS. You can actually contribute here. We do encourage it. Please, if you have rules that you've built and you want to share with the community, go ahead and publish a pull request. We published all our testing frameworks as well. So there's all information about how you can test and contribute and test the efficiency of them as well. So do keep this in mind. And it's elastic/detection-rules. If you want to contribute, we totally encourage it. So that's pretty much it for my demonstration today. I haven't really been keeping an eye on the chat. It hasn't been too busy, it seems. But there seems to be one question there.
Thank you, James. Yeah, let's go ahead with the Q&A. I mean, if you're finished.
Yeah, I am from the presentation side. So there was a question about, so can I use either Logstash or Beats to analyze generated network logs and metrics in open source Snort IDS? Yes, you can. So it's totally your preference. Most of the time, you get away totally enough with Beats. You can use both in combination if you wanted to, but again, most of the time that's extra. So you can choose either Logstash or Beats. My recommendation is always Beats because it's a bit more performant and a bit more lightweight as well. But yes, you can.
Awesome. Thanks, James. Anyone else? We have time for questions.
All right. I mean, if you can't think of any questions now, that's totally fine. And I do encourage you to join our Slack workspace. So I have a totally open community Slack workspace. So you can get that detail. I'm going to put it in the chat in just a second. But it's basically ela.st/Slack. So you can send you a link to join our Slack workspace. So do ask any questions there. I'm on there as well as 3,000 community members and a handful of Elasticsearch engineers as well. We have another question about the licensing for security. So pretty much 95% of what you saw is totally free in the basic license. That includes the upcoming endpoint stuff. So we don't really have the concept of Elastic of having a different license for different parts, security being one of them. We do, of course, have commercial features. So things like the machine learning, the case integration, external actions, those are commercial features. So basically that's priced. We have a pricing model there. It's basically based on memory to run the Elastic Stack. But we don't charge on things like ingestion. We don't care about EPS. We don't care about how many endpoints you have. It's all about the requirements to run Elastic Stack. So there's a question about the query language. So first of all, it's the EQL stands for Event Query Language, not Elastic Query Language. It is not generally available. So in the next release, it will be as experimental as part of an API. You can already see the docs. So if you go on our website on the master branch of the docs page, you'll see it there. Eventually, it will make its way to generally available, but no, in the next release, it will be actually experimental.
Awesome. Thank you, James.
No worries.
Everyone, we would really like to hear your opinion about the meetup, the content, and also what would you like to hear in the future, like what kind of topics you're interested in. So I pasted the link to a survey in this chat. If you can answer a few questions there, that would be great. So we can improve for the future. And of course, we would like to do what you would like us to do. So whatever you want to hear about, please let us know. Yeah, that's it for me. James?
That's pretty much it for me. Thank you all for joining. It's a small number, but it's still hopefully you get quite a bit of information. Again, there's no such thing as a bad question. So I really do encourage you to join the Slack workspace if you do have questions. If you prefer, we have our discussion forums as well. So it's discuss.elastic.co. Yeah, just ask away. And hopefully you have a great evening, depending on the part of the world you're in. And we'll see you next time.
Awesome. Thanks, everyone. This will be recorded, by the way, and put on the YouTube channel of Elastic. So we have all of our recordings from the meetups there. So whenever you would like to watch them, you can find them on our own channel there. So yeah, thanks, everyone. Have a great evening.
Thank you all.